It's a real honor to be here and a bigger honor to follow Dr. Huber and to share the podium with the group of people we have here today. It's pretty amazing. I just want to acknowledge that and thank all of you for being here. It's just, we're learning a lot today. What I want to talk about is where that glyphosate comes from. And we use mass spectroscopy for the testing that we do. And it is, for me, I've been in molecular biology and biochemistry for 20 years, well, more than that, 35 years. And most of the time I was using genetic methods, studying on the DNA and RNA level. But I've fallen in love with these mass specs. They are like X-ray vision. It is really powerful. So what we're going to be talking about is something that at the time that glyphosate was commercialized, you couldn't do this kind of thing. But now we can. Now let's see, how do I turn this? I think this does it. Okay, and this is what we use. This is a liquid chromatograph on the left-hand side, and a time of flight mass spectrometer. And it's about just a little bit smaller than a Volkswagen Bug. It's a serious machine. Just the two key things here, HRI, Health Research Institute, is accredited as a high complexity clinical laboratory, CLIA accredited, and we also have ISO IEE 17025 accreditation, which is the ISO accreditation for analytical laboratories. And we look at all sorts of things, and I'll tell you more about that as we go on. The key parts of it is that we look at the good things and the bad things. We use what's called full spectrum nutrient density analysis to link the connection between, to establish that and study that connection between farming practices and nutritional density of the crop that comes out of it. And we also look at the bad guys, the contaminants, and we focus on pesticides, veterinary drugs, antibiotics, hormones. And among those, we have glyphosate. And that's actually a big focus of what we do is the work on glyphosate. Testing shows that pesticides, especially glyphosate, are pervasive in our environment. And this has health consequences, both for the crops that are being grown and for the people who eat those things and the animals that eat them. And here is just showing the glyphosate exposure levels. This is a paper that we published in the Journal of the American Medical Association. And what it shows is that from the time glyphosate entered the marketplace, its level of exposure in the population increased by 38.5, almost 40-fold. Huge increases. And so we've also done another human exposure study, and this wasn't completely unbiased because the people who took these tests were interested enough to pay for their own test and to understand what their levels of glyphosate burden were, the body burden of glyphosate. So these are probably people who are already concerned about their health, and therefore the levels that we observed were probably lower than in the average population. But we did 2,500 people, 76% of them were positive for glyphosate. And men had more positives than women, and people who consumed oats regularly had twice the level that other people did. And that's because oats are desiccated with glyphosate very, very often. People who consumed organic or 75% organic in their diet had 80% fewer positives and significantly lower average levels. And people who ate 6 or more helpings of veggies every day, those are people who are really sort of careful about their diet, had 50% lower levels. So that was, and the average concentration that we saw in urine was 0.4%. Interestingly, notice in this study that used a more random selected group, by 2015, the level was 0.77%. So pretty significant difference there. So there was some selection in this study. Glyphosate we also measure routinely in human hair. And you'll see here quite high levels in human hair, actually. And nanograms per gram, 100 nanograms per gram in this highest one. And AMP is a little lower, but we see it. And so in this same group of samples, we see everything from almost no detectable glyphosate to massive detection range. It's a pretty serious thing that way. And the next two slides are just to show you how pervasive it is. And this we call the roadkill study. I had one person in our lab who one winter went around and collected hair samples from roadkill. And it was more pleasant to do that in the winter and in the summer because they're sort of frozen, you know. And we found all sorts of things. We had deer and mouse and possum, one owl, some rabbits and raccoons and squirrels. And the one that blew my mind was the deer. Look, we have a deer that has massive levels, and at the same time a deer that has almost no glyphosate in their system. And I was mystified this until I had a conversation with a naturalist that is a friend. And they said, well, deer seldom stray beyond a mile from where they're born. And therefore, if there was a field of glyphosate, a field where there was a lot of glyphosate used on corn and soy, as happens in Iowa, I'm from Iowa, you would actually see that deer having high levels. But if they were in the forest, they might not have any glyphosate in their system. And so we see the same range. Interestingly, the same thing with rabbits, high and low, and on like that. And you ask, well, now, why does an owl have glyphosate? And that's because the owls eat mice from end to end, and and the mice eat glyphosate, and so they get it. So this was a mind blower for me. This stuff is all over the natural world. But then the next one, compliments of Gilles-Éric Seralini and other French scientists, was our Antarctic penguins. They sent us feathers from 10 penguins, and out of those 10 penguins, 3 of them had high levels of glyphosate, and the 4th had a significant level of AMPA. And then there were traces in a number of the others. Now, these are animals that do not migrate. They live their whole life on an island right next to Antarctica. What's going on here? Well, it must be that there's some fish migrating, and they get to eat those fish, and they get the glyphosate from that. That's the only thing we could figure out. It's absolutely mystifying, but they're there. And it says glyphosate is everywhere in our environment. Now, I want to talk about regulation a little bit here. And what you see in this slide is some organic products and some conventional products. But you see also these red lines. And these are the recommended safe levels of glyphosate. EPA says you can safely eat 140 milligrams of glyphosate a day. That's about the size of an aspirin tablet. It's okay for you to eat that much every day. It's safe. Now, the European government, their food safety agency says that, well, actually, 35 is the upper limit of safe. And then you ask, well, okay, California is squeaky clean about these things. What do they recommend with Prop 65? And they say 1,100 micrograms is safe. So 140,000 micrograms versus about 39,000 micrograms in Europe and 1,000 micrograms in California. Would you say that that indicates that these regulators who set these things really understood anything about the safety? How could they be so far apart and be really meaningful? They're really, and when you look at it, these really are set by industry pressure more than anything else. It's corporate capture of our regulators. And interestingly, we looked at the California safety assessment, and basically it still allowed one case of cancer in 100,000. Now you extrapolate that to the California population, and it's saying that the California regulators say that it's okay for 390 Californians to die from glyphosate, and it's considered safe. Now, what we did is we looked at that and we said, now, this is for healthy adults. And so for vulnerable populations like new babies, or for mothers that are, pregnant ladies, or for older fogies like me and things like that, where our systems are not quite so healthy as they should be, and so we can't detox as much. And so really, if we knock that down another 100-fold to 11 micrograms, you're probably then in a region that's reasonably safe. But then along comes some of from Gilles-Éric Seralini and some of his friends, a study that showed that at those kinds of levels, you still have glyphosate causing what's called non-alcoholic fatty liver disease in mice. So it's still, and probably if it's doing it in mice, it's probably doing it in people too. So even at those lowest levels, you're likely to have health impacts. It's really a bad situation. And glyphosate is everywhere. And it starts where? In the soil. Yes, it gets sprayed, but as Don was saying so clearly, there's this reservoir of it. It keeps accumulating in the soil because the soil actually is capable of binding very large amounts. And the microorganisms, whenever the situation is in the soil, the microorganisms will liberate some of that glyphosate and it ends up in the crop. So it's there. And here we're really looking at one field that's had glyphosate like every 10 years, or for every year, 10 years. And so you're getting it quite frequently that way. The other one it's been several years that it's been without glyphosate. And notice that glyphosate is lower than AMPA. So AMPA is more stable, it stays in the system longer, and so it creates those problems. So that's where it starts, is in the soil. But I'm going to take you through some other stuff here. So fruit. Now, why would there be quite high levels of glyphosate in cranberries? Well, that's because they control the weeds in the cranberry bogs with glyphosate. And that's the case with all these fruit, is that they're doing, and notice with the green bars are organic, and so they're a little lower. So they're below, we call it a child safety limit. That's what we were talking about up here for the 11 micrograms level there. And so that's what as we go through these, you'll see child safety limit coming up quite frequently. So you see that in, any fruit that you get. And then yellow potatoes, they actually desiccate potatoes sometimes with glyphosate, but it's probably from other, from the field being, sprayed with glyphosate years before. Here are some more. Tea and chocolate. So there's glyphosate in your chocolate. It's lower in the organic, but in tea, you see heavy usage in the tea, in the tea fields. And so you see quite serious things there. Even in organic, you're seeing it to some extent. Oats and cereals, again, these are crops that are frequently, almost consistently sprayed with glyphosate as a desiccant before harvest. And that shows up, how often does it rain on the crop between the time they spray with the desiccant and they harvest? At least half the time it doesn't even rain. So you're getting the full dose of glyphosate when you go through that. Legumes, same thing, heavily desiccated. Bread, same thing. Wheat is one of the most consistently desiccated. And here we see that organic and also gluten-free are lower than most of the others. It looks like now conventional white bread is lower, and that's because you've cleaned out the parts of the wheat that can where the glyphosate is lodged that way. Beverages. This is your wine and beer and things like that, and it's you see them there. It's not much, but it's heavily processed material. The conventional organic or orange juice is one of the highest because they do desiccate or they do control weeds in the fields with glyphosate. Dog food. How many of you have had the experience of your loved dog dying of cancer? This does happen. And in fact, I have heard the statistic that something like 40% of dogs at the time of death have cancer of one sort or another. It may not have killed them, but they have it. And so the quality of dog food, don't feed your pets kibbles, please. Feed them something else because the kibbles are full of glyphosate. We've tested these over and over again. Then here, these are, we all love Cheerios. Well, here are several different examples of Cheerios full of glyphosate. And then here we have beans, and again, a lot of exposure there. And again, some wines, and there are some, the Argentinian wines were the highest, interestingly. That's the only thing I would say. Get yourself California wines and organic, and then you're probably going to be okay. I want to just end by saying that, the pesticide issue it's serious with glyphosate, and that's what we're focusing on here. But it goes way beyond that. And this is a study that we did just in Fairfield, Iowa. We've got a Walmart there, a Hy-Vee, and we have a local sort of natural product store. So we got a bunch of foods from each of these, matched them up, and we got from the natural one, we could only get organic. But from the other two, we got organic and conventional. And there's as you can see, every green mark in there is a detection of glyphosate. So the columns are different. Maybe I can point with this thing. Maybe not. Doesn't look like it. The columns are different samples, and the green is organic, and the pink or orange or whatever it is the conventional. I'm not going to go more into that right here, except just to give you the summary of these. And there's some interesting things here. The average pesticide level in organic from Walmart was 1.67 nanograms per gram. In the conventional, it was 75. Hy-Vee, the organic, was twice as high, 3.23, and the conventional was almost 400. And then the everybody's, the organic was 5.2. And the top level was 25, whereas it was 14 with Hy-Vee and 4 with Walmart. The thing that blew my mind here was that, and then if you looked at the highest level, you see in the Walmart organic was 4, we said that it was 4, the Hy-Vee was organic was 14, the everybody's was 25, but the highest levels in your conventional were almost 500 in Walmart and almost over 2,000 in Hy-Vee. So there was an average that was significant in those stores, but it's also a crapshoot. If you happen to grab the wrong thing, you could get a huge dose of glyphosate. And also with glyphosate, it's a bit of a crapshoot. You're not getting 0 in all of those things. You're getting quite a lot higher in some of them. So in each case, there were a few products, even in the conventional, that were free from where we didn't detect glyphosate. And that meant they were at the nanomole level of glyphosate, so or less that way. Now, the number of samples with undetectable was 2 to 4 in the glyphosate or in the organic, and 1 or 2 in the conventional. The average number of pesticides present, this really got me, at trace levels was in the organic was 2, 3, 2. In the conventional, it was 4, average, okay. And then total number of pesticides in those was 4 in the Walmart organic, 8 in the Walmart conventional, 4 in the Hy-Vee organic, 9 in the Hy-Vee conventional, 3 in the everybody's organic. So those were measurable levels of pesticides. And so you can see that if you're eating a conventional product, it's got somewhere like 8 pesticides that are there, quite high. And there is a factor to keep in mind here, and that is that there is synergy between these things. So even if you have several that are present in trace or low amounts, you put them together and there's going to be more problems there. So this gets pretty depressing. And these thresholds should be changed, and they should be based on scientific safety, not on lobbying. And right now, it's all lobbying. But there's some good news. And I'm going to tell you a couple good news things. How are we doing? Good. I've got a little time here. I was going to skip this if it hadn't gone too far, but I think it's worth doing. Our bodies, the first good news is that our bodies have the ability to eliminate toxins. So if you eliminate the toxins, they go away from your body pretty quickly with many of them. With some of them, they don't. The old organochlorines, they stuck around for a long time. And it looks like the organofluorine pesticides that are now being foisted on the agricultural community have even longer half-lives. They are really forever chemicals. So here's the question to all of you. I would bet that every person in this room envisions that one of their children at least is going to take over the farm when they retire. Now, if it has been polluted with organofluorines for 20 years, is that land worth farming? Will there be regulations that come up that say land that has these levels cannot be used? And because these things are so slow to degrade, they will take that land out of commission for 30 years or 50 years. The legacy for your children is being taken away by the chemical companies who've foisted these things on the agricultural community without really even telling them that this was a problem. And yet they knew it when they did it. Here was their logic. It's like, well, okay, so they're not going to let us use organochlorines anymore. Well, let's use organofluorines. They're even more stable. These are the people that so many farmers are going to for advice about what to plant, what to use on their fields. This is not it's not right. So anyway, to get back to the ability of our body to purify things. I get off, I apologize for that. It's one of the things that really frustrates me. And we're very interested in looking at detox of organofluorines in soil and in people. So here was an experiment I did on myself. 5 days I ate Quaker oats twice a day. And I knew that it was full of glyphosate. And then the next several days, I ate organic diet in a really strict way. I'm usually pretty careful, but I was squeaky clean careful. And here's what happened. So the red line is the glyphosate, the green line is the AMPA. And what you see is that within 2 days, or 1 day, you're getting rid of 80% of the glyphosate in your system. The glyphosate in your urine goes from 2,000, from 2.0 down to 0.35 or so. And then over the next couple days, it goes down to baseline. Doesn't go to zero because there's some of it that it's lodged in really it interacts with the minerals in your bones and is stuck there. And there are some other places probably as well. And so it stayed low during that next period. But then one day I went out for lunch at a restaurant that was supposedly organic, and I had an organic pizza. It really tasted good. But the next morning, glyphosate was up again just from 3 pieces of organic pizza. And again, it took 3-4 days for it to drop down. So the good news from this is that you're going to be in good shape. Your body will do this to take care of you. And so But on the other hand, you have to cooperate with it. You have to be discriminating in what you eat so that you're going to avoid these things that are going to be toxic. So the problem, because glyphosate and pesticides are pervasive, what you eliminate today is replaced tomorrow. So it stays up there because you're eating the stuff every day. We are inundated by these things, and when you have I've said this already, multiple low levels of pesticides are probably as bad or worse than high levels of one. So that's there. So HRI's strategy with regard to pesticides is to create transparency. We wait around for decades for government regulation. We wait around equally long for industry to clean things up themselves. But if you create market demand, things are going to change. And so our hypothesis is create transparency around pesticides. And that gives people, and around the nutritional value of foods. When that happens, people make good decisions. They want their kids to have safe food. They want their kids to have food that's nutritious. And this is what they'll get if and they can choose in the marketplace for the things that are better in that direction. And that's going to create demand for pure, safe, and nutritious food. So market demand driven. And it's simple. Healthy soil, healthy food, healthy people, healthy planet. Comes right back to that. And it's going to be the moms and dads that make this successful. But if you can give the consumer at the point of purchase information that allows them to choose the better product, they're going to do it. And let's hope we can make that happen soon. One last thing I'm going to do, I've got a few more minutes here. One last thing I wanted to talk about is nutrition density very quickly. We're doing a lot of work in that area. I'm going off topic here, but I hope you'll find this interesting. And it's really fast. Nourish. That's what crops are about, is nourishment. But as one of our speakers already today pointed out, I think it was Dieter, that growers are rewarded based on yield. They're rewarded based on the amount of crop that they deliver to the grain elevator. They're not rewarded much, if anything, for the nutritional value of that crop. It has to meet a certain very low level that's set by the federal government, but mostly it is simply yield. And so, you hear farmers now sometimes talking about, at least some of them, who aren't talking about the yield of their crop. It's how much product they produced. But basically, the tradition of agriculture has been feeding your family and feeding your community. It has to do with nourishment. And right now, that's not part of the equation. And so what we say is, if you want to fix something, first figure out how to measure it. And so we're working on measuring nutrient density. And I want to give you a sense of what we do with that by showing you a report that we give. We're doing this mostly with wheat now. We're doing a really interesting project with grass-fed beef, fermented grass-fed beef. And tomorrow, Ken, what's Ken's last name? Ken, tomorrow, who will be speaking, will be talking about this work, I think. But anyway, we've been looking at this. And so this is a report like we give to people who are doing the wheat nutrient density testing. And so it does three things. It gives a molecular level. We look at the nutrients at the molecular level and build nutritional density from the ground up on that basis. And then we pull that together into functional scores, and then we get from that, we roll it up into an overall nutrient density score for that product. And I'll skip that slide, but this just shows you the molecular level of what we're seeing. And here we've got three lots of wheat. We've got one of them, this is an Albrecht wheat actually, grown, using the Albrecht mineral supplementation program. And you'll see the orange is the highest one in most of these. And then there's a grand average, and that's an average of all the wheats that we have tested to date. And then we have, this one is the green one was the sample that the grower brought in. And so you can see that we'll just spin through this quickly. Here's another slide of some of those, and then more. And then the next, these individual compounds, this is a discussion of that, but here, our property, these are the compounds that were higher in this person's wheat than in the grand average. And their goal, of course, is that in years to come to be achieving levels of nutritional density that you have with the Albrecht wheat. So this talks about the different compounds that were higher in theirs and why they're better, basically the properties. And then we look at nutrient density. We take all of those compounds and we put them in categories based on their function. And on that basis, we come up with this, which is a set of functions of different kinds of compounds in that. And again, Albrecht is sort of knocking the socks off everything else. But there are several cases, the non-protein amino acids, the nucleic and nucleotides, the vitamins, the intermediary metabolites, and a few others, where the grower's wheat was doing a bit better than the average. And then what we do here, this actually is those same scores as numbers, but we make a total nutrient density score out of that. And we see again, the hard red Albrecht wheat is quite a lot better than the grand average. And the grower's sample is also a little better than the grand average, but still has a ways to go to match the Albrecht. So it's like by giving both of those comparators, we can say, okay, this is what the average is, and here's what you can aspire to achieve with your own growing. And that is useful. It's like a guide star. It's like, okay, this year I did better than last. What did I do different that made a difference? So that's interesting that way. And these, I won't go into detail here because we don't have time to talk about all that stuff. But just to summarize what the aim is of our nutrient density work is to give growers a way of measuring the nutritional quality of their crop. And this gives interesting opportunities. Premium prices are potentially something that can come out of that. Currently, there are some opportunities for that, but that's something that if nutrient density were something that was really people were aware of more, this could make a huge difference in the marketplace and with, in a powerful way. So that's one opportunity. The second opportunity is that it gives opportunities to much more rapidly improve the nutrient density of your crop. First of all, just doing this test every year, you're going to see what you did this year different and how it improved things. But there's something else. We are putting together a database where it has the agronomic management practices that a person uses, that the grower uses, and the nutritional density of what they got. And so what you can do is to look at what, this gives you the opportunity to learn from what other people are doing and see, oh, these guys did this and this, and look at what happened over here. And so you begin to learn more to more rapidly move your crops forwards. So on that, hopefully more positive note than glyphosate's going to make you sick and make your crops sick, there's something more that we can do, and when we do it, it's going to be a better agricultural system and a better world. Thank you.